Hello and welcome to our next video. In this lesson, we're going to go over a general welcome to computer programming. We're going to cover some thoughts, tips, and strategies that you can use when you're learning any programming language. So this is not just for Java, but any language that you want to learn. So we're going to start out in this lesson by covering what I see as an instructor as being some of the biggest mistakes that beginning programmers make. I'm then going to present a few tips and tricks for learning some strategies that you can use while you're programming. Then we'll take a little bit of time to talk about the fact that learning programming takes time. I also want to talk just briefly about what you might do if you have a textbook, some additional supplements, or other code that you can work through. And then we'll finish up by talking briefly about how we can, as professional programmers, leverage some other things on the internet for a little bit of help while we're building our code. So what is the biggest mistake, or what are the biggest mistakes that beginning programmers make that I see? The biggest mistake that students tend to make, or that people learning programming tend to make, is everybody wants to just jump in and start programming. If you were to sit down today and try to write the Sudoku code that we're going to use to write the Sudoku game by the end of this course, you would have a real hard time understanding any of it, if you could understand any of it at all. That's because you're just getting started, and that's expected. You're not supposed to understand it. The code is available to you on that last lecture, but what good is it going to do you if you can't reproduce it? The big problem is a lot of people want to get going. We need to get going. We have no time. We have no patience. And so what happens is we want to go right into that solution and just learn how to program from it. That's not going to work. Well, it might for some people. But the best solution is just start from the ground up. Take the basic building blocks of programming, learn them as you go, and continue to build on those skill sets as you grow. At times you're going to make a few jumps. It's just part of the nature of the game. But most of the time you want to take small steps so that you can continue to grow and not miss out on some of the important aspects of programming and be able to reproduce code later on of your own, not just use someone else's code. And that brings up the next point. A big mistake that students make, or that anyone makes, is just trying to use code written by someone else that you don't fully understand. Now, if you're a student, this is a really bad idea because it's plagiarism. So what you want to do is make sure that anything that you write as code or present as code that you've written is something that you can defend, something that you could explain line for line what each line of code is doing, why variables are named the way they are, what's going on in this process, what made you decide to put this piece of code here. If you're a student or if you're just learning how to program, another big mistake you could make is trying to just sit down and do your homework immediately, or trying to sit down and write that big project without taking the time to learn the concepts. What's going to happen is you could get started, and immediately within about 3 or 4 hours, you're going to start getting what I call pulling your hair out syndrome, where you're basically going to be so lost and so frustrated that you may actually just give up on the course altogether. And that's a really bad thing. So give yourself the time and the patience and the permission to take the time to learn the things that you need to learn. So a couple of different things to think about with this are, if you were a marathon runner, would you go to the marathon day and expect to be able to run 26.2 miles without ever having run a mile before that in training? Again, there are a couple people who naturally gifted would be able to do that, but almost everybody would get hurt or be sore or definitely not be able to finish that race. The same thing happens if you're learning to play the piano. Would you go to your recital and try to play your music without practicing in front of a bunch of people? You would end up being completely embarrassed. So let's talk about a couple of learning strategies then. Some things that we can use to retain the things that we're actually going to learn in this course. Again, start small and build from there. Every time you add a little piece of knowledge to your skill set, you should practice it. And you should be able to explain what you're doing to someone else. You should be able to tell them, this is the code I'm writing. This is why it works the way it does. Again, take the time to practice. Run those miles to get to your marathon. Play that piano piece over and over to get to your recital. The same thing happens with programming. Start with a small problem. Work it out. And then do another one that's very similar so that you can, again, repeat those actions and get that muscle memory in place. What we're going to find and what we're going to see real shortly is that we actually want to sometimes break our code on purpose. It's a real good way to see a few errors happen and be prepared for them in the future. And again, don't just do the bare minimum here and then walk away from your code. That's like sitting down, writing your homework and quitting right away. Because what's going to happen is you might make it through the first couple weeks of your course, and then you're going to fall flat on your face when you can't reproduce that later on because you haven't practiced it enough. And your projects are going to continually get larger, and you're going to need to be able to do these things as you go in a cumulative manner. It's just the nature of programming. Some additional strategies that you may not have to do right away, but are really good to start thinking about as programmers. Learn how to plan out your code. Now, this could be charting, pseudocodes, algorithms, and you'll learn about those things as you continue to grow as a programmer. But if nothing else, everybody should be able to make a task list. Put a little square next to the task and say, I need to write this code for computing 2 plus 2, or whatever it might be. And when you get that done, you can check it off. Now, it's good in two ways. Number one, it helps you plan the program so you don't miss anything. You can also then think about what you're going to do and see if you actually maybe would have had a flaw in your logic before you even start coding. And number two, gives you kind of a little boost every time you can check something off and say, hey, I've completed that. Look at the progress I'm making. Again, it's going to take you time. So plan to take the time. Learning to program is an investment, and it's an investment in yourself, in your future, and in your skill set. Why does it take so long? Well, as it states here, nothing worthwhile ever comes overnight. And that's kind of a cliche, but really it takes a long time to learn something worthwhile. One of the things about programming is you're never going to stop learning. As you continue to learn how to program, you will actually see things that you maybe didn't know later on as well. There's a lot to learn. Things are going to change. Standards are going to change. Languages will generally stay the same in the syntax, but different function calls or method calls might pop up along the way that you'll learn. I always think about it, if you can look back at your code that you wrote 2 years ago, and you can't look at that code and say, man, I wish I would have been able to do this, or man, I wish I wouldn't have done that, then you haven't grown. And that's a real bad thing in programming. So make sure you're always able to say that. That means you're continuing to grow as a programmer. One other thing that's a little tricky about programming is that the most obvious solution is not always the best solution. Now, again, as you grow as a programmer, you'll start to learn things about efficiency and algorithm efficiency and different data structures and how you'll use those data structures in different ways. So there may be ways to do things. With programming, there's always multiple paths, but the best path may not be the obvious path. You may have to think about things down the road. And so this is why it's going to take so long, because just like learning any job or just like learning any task, you can do things and then you can find out there are better ways to do things. Just because you've done them for so long, you see better ways. So a brief note for those of you who might have a textbook, a supplemental code section or supplemental readings or code that you can use. And we also will have code with this course, so this applies to that. But basically, when you have these tools, you need to be real careful, because if all you do is just read through a textbook, you're never going to be able to repeat that. What I'd like to present to you is, if you're working with a textbook, make sure that you're actually working the textbook. Now that means reading it and typing out every single thing that's in that textbook, line for line, letter for letter. Now what will this do for you? Yes, it will take time, but it will give you the ability to see where you're making common mistakes in your coding. Now this is going to be really important, especially if you have to go take a test where you don't have the benefit of a compiler, or you have to do a job interview where they give you a piece of paper and ask you to write a snippet of code. By having practiced that over and over again, you'll be ready to note exactly what you need to do, and you'll know where you will make those common mistakes in some of the syntax. So you'll be ready to prevent yourself from doing that in an important situation. If you have some materials, if you can reproduce it, that's great. But if you can adapt it, that's even better. So make it work for you in a way that works for you. For example, if your first program is print out your name, print out your exact name. But if it's something like print out the quick brown fox jumped over the lazy dog, sure, make that work, but then change it to a different sentence and see that you've actually been able to adapt it. Now that's going to stretch you. Make sure that you're understanding the code. Finally, and this is a really touchy subject, especially in the academic world, but Google is your friend and Stack Overflow is even better. Now this is important in the programming world, because what's going to happen is there are going to be times when we all get stuck. But what we should never ever do, especially in the academic world, is just take someone's code and present it as our own. So we can go out and we can find some help. We can ask questions about our code, and we can find code that's similar to what we've done, and we can adapt it. But again, if you're in the academic world, make sure that you never turn in code that you can't fully defend. So if you find something that works, just because it works, you better be able to make sure that you know why you did what you did, or you could get yourself in a lot of trouble. Now, in the professional world, hopefully once you're in your job, you would be able to read the code and say, this is what it's doing, and understand it and adapt it for the system you're building code for, which is the main purpose of situations like asking questions on Stack Overflow. And I want to point out a couple things too. When you're asking questions online or asking questions on your instructor, there are bad questions. I know that you were told there's no such thing as a bad question, but that's absolutely wrong in programming. There are bad questions. For example, why doesn't my code work? I don't know. What's your code supposed to do? What language are you writing in? What have you tried to fix it? What errors are you getting? There are a multitude of things you didn't tell me if all you ask me is, why doesn't my code work? There's no way that I can answer that question with anything other than, I don't know. I can't help you. So if you take a look here, I wrote a little snippet of just a blurb of what might a good question look like. It's basically structured. It has what you're doing. If you have a reference, where you were working from. You tell the person you're asking exactly what you thought you were trying to do, what errors were going to happen, what causes the errors. The fact that you're stuck is kind of obvious, but you can restate it. And then tell your instructor or tell the person you're asking what you've tried, because they might be able to see where you went wrong, where you tried something. I tried to do this, but nothing worked. Well, when you tried to do this, did you make sure to do this? And then all of a sudden it works. And so another thing is, of course, give a good snippet of what's actually causing the problem or where you believe the problem is. So basically, that's it for our welcome to computer programming. And again, these are good things to remember no matter what programming language you're learning. And so I hope you will take this forward and use this to continue to grow as we work through this course. And again, I'm looking forward to working with you, and let's go ahead and get started. Thank you very much. We'll see you next time.